the continuation of tutorials on Seaborn for Python. If you haven't seen my previous video on Seaborn, I'm going to run you through the basics of Seaborn really quickly for the purposes of this tutorial. But having said that, you can always click on the link up the top right, see my first video on scatter plots. Before we deep dive into Seaborn line plots, I would like your attention on this graph because it's really important for understanding the general construction of Seaborn. So Seaborn, as opposed to Matplotlib, has some higher up overall functions that the little functions are built underneath that. What does this mean? It means that, for example, if you want to make a scatter plot, as you can see on this graph on the photo, or a line plot, you don't necessarily need to call the scatter function or the line plot function. You can easily call the rel plot function, and underneath that say that I want a scatter plot or a line plot. So that makes life just a bit easier. You just need to remember one function and the kind of graph that you want to get. For example, if I wanted to get a scatter plot, I would say I'm going to choose Relplot, and I'm going to say the kind is scatter. Very easy. The same applies, for example, for hist plot, KDE plot, ECDF plot, and RUG plot, or the ROG plot. All of them live under one function, which is the dis plot. You just simply say the kind is KDE, the kind is hist. So essentially, you just need to remember the name of one function and then the types of functions that live underneath that. This is pretty important to remember. So in my previous video, we talked about scatter plots. And today I'm going to run you through very interesting types of line plots, how to make them really appropriate for our data, and how to present them to the people that are sitting in a room waiting for us to tell them what is going on. Let's go ahead and make a new Jupyter notebook. Give it a proper name as we always do. Call it Seaborn underscore number 2. And this one is for line plot. Like always, import Seaborn as SNS. So that's the alias name. And just in case, import NumPy as NP in case we need it. The beautiful thing about Seaborn is that it has some built-in data for us to use. So if you're just trialing with Seaborn and you don't have any data to play with, no problems. Stay tuned. I'll show you how to use the data that Seaborn gives us for free. Let's load the flights dataset from Seaborn library. So SNS load dataset, and the name of the dataset is flights. If I do this, you will see that there is a data set that has the year, the month, and the number of passengers. This must be a data set for one of airlines. How many people flew with this airline over the year of 1949 and the month of January. Let's write this into a variable called flights. We can always look at the top 5 rows of flights to understand what the data structure looks like. Scatter plots and line plots are mainly different in one thing. We use line plots for things that the continuation matters to us. It's not the patches of data, whereas it is the continuation sometimes over time of some variable that we really care about. For example, the number of passengers. We want to understand how many passengers over time flew with an airline. So remember that. Line plots for continuity, not necessarily over time, but also over some continuous variable as well. So sns.relplot. I'm going to use relplot, but I'll also show you how to use the line plot function. So I'm going to use relplot. I want the data to set that to flights because that's the data I'm using. And X will be the year. Y will be the number of passengers. If I run this, here's the initial result. What we can see is that for every single year over the X-axis, there are multiple entries over the Y-axis, and those are for different months. So there is a January entry, February, March, and so forth for every single year. That's why we have markers sitting on top of each other in a vertical direction. And the second thing I wanted to mention is that, well, by default, this is not a line plot. So if you use the rel plot and do not tell it to make a line plot, it will make a scatter plot. Because by default, the kind is scatter, and it's not going to change if I do this. However, it would be really nice if I could make a line plot out of this, which would capture that range of change from January to December. And that's one of the coolest functionalities of Seaborn Relplot. If I change this to line, you will see that now I have a line plot with interval around it. And what does that interval really show? Well, that interval shows that range of change from January to December for every single year, which is really cool. So the way I would present this graph, I would say over the years from 1949 all the way to 1961, not only the number of passengers flying by this airplane has had an upward trend based on the graph, but also the interval of change has also grown. Previously, it was a really tighter line plot because it was ranging, for example, from 70 people to 120. However, now it ranges from 400 to 550, which is a bigger range of variance. And that's how you can present that. So this is using the Relplot, which is the overall function that has scatter and line underneath it. So if I were to just say, I want to use the line plot, so I need to get rid of the kind parameter because line plot is a line plot. You don't need to say kind equals line. If I run this, I will get a very similar graph. Personally, myself, I would really like to use the rel plot and set the kind to be line or scatter, depending on my data. Now, one interesting thing you can do, you can actually say, I'm only interested in the flight data over the month of February. So what you can do, you can say feb flights, equals flights dot query, which is a method from pandas. You want to query a specific month, and you open quotations, say month equals in quotations February, and that's going to be the Feb flights. Now, if I make a line plot of data equals Feb flights, and x equals the year. So I want to look at every year, the month of February, and y equals passengers. So if I plot this, I am only looking at the month of February data. I could do this for every other month as well. Going back to the bigger data set, I'm not going to look at Feb flights anymore now. I'm just going to go back to the flights data. So the bigger data, let's just look at the head again. Flights.head is every year, every month, the number of passengers. We can use the same syntax for the line plot. So line plot of data equals all the flights, and x will be the year, y will be the passengers. And what I can do, I can add a hue parameter and set the month for that. What it does, it will draw a line for all the Januaries in all those years in one color, another color for Februaries all over the years, and so forth. If I run this, you'll see that this color is for January, February, March, April. Probably I'm going to use plt.figure to make this fig size just a bit larger, 7 by 7, but this is not going to work because I haven't imported matplotlib. I'm going to go up the top. I'm going to say from matplotlib import pyplot as plt, so it will work now. Let's go down, run this again so that we have a bigger graph. It's interesting that around August and September, these blue colors are where the number of passengers are the highest, which makes sense. September has always been the peak of traveling for people. If I were to make it just a bit more fancier, I can use the style parameter. I don't have any other columns that I can set the style. For example, if there were different types of airplanes, I could draw different styles of lines for different airplanes. But for now, let's just say I'm just going to set that style to the month as well. So a solid line in pink is for January, dashed line is for February, dotted line is for March, and so forth. But if I had a separate column, I could set that to that as well. As I said, Relplot is the parent function for line plot and a scatter plot. So I could easily just replicate this same thing using the Relplot. All I need to do is to make another PLT figure of fig size of 7 and 7 if you want to do that, and then use Seaborn Relplot of data equals flights. The x is the year, and the y is the number of passengers. So if I run this, you will see what we saw in the first place. I'll add a hue of month, which will add a hue to it. all I need to do is to set the kind to line, and I'm gonna pretty much get the same thing. If I were to set the style as well, I can set month as the style. So I'm gonna get pretty much the same thing with the Relplot, but the beauty of that is that I can just switch from kind of line to scatter to give me a scatter plot. However, for this type of data, which is over time, I prefer a line plot. Okay, and like always, let's add a title, number of passengers over years. That's the title. Let's put a semicolon so we don't see that print. If you haven't seen my previous video on Seaborn, one of the other things that was really handy with Seaborn was the use of categorical variables to make different plots. Say, if you have some data about January, February, March, April, May, June, and all so forth, if you want to separate them in different plots, you don't want to put them like this on top of each other. You want to say, this is a plot for January, this is for February. So you can easily do that. Let me show you how to do that. I'm just going to move the aesthetics to the next line, and you can set the columns of graphs. You want to say, give me 5 columns because I have 5 different categories. Here, because it's from January to December, you have 12 categories. So if you use the month for column like this, you will get 12 columns. Let me run this. It's not going to be really visible because they are very small. It's trying to push 12 graphs side by side. But if instead of column, I set it to row, I will see 12 rows. So now you can see this is for month of January, this is for month of February, this is for March, and all the way down. Not really the best way of showing this graph, but I just wanted to show you that this is possible. Okay, that's it for this lecture. I hope you enjoyed it. I would appreciate if you like the video and subscribe to my channel. Thank you.